Alright, so now let's do a very cheating and quick proof of all these identities. So usually when you're trying to prove all these things, you need to use a lot of triangles, a lot of unit circles, and a lot of nonsense trying to get the values and get to simplify all these things. However, all you need to do, just learn the Euler's identity of sine I theta is indeed cos theta plus I sine theta. If you know how this works, that just makes life so much easier, because now I have e to the power of IA multiplied by e to the power of IB equals to e to the power of IA plus B. And this is equals to, wow, look, cos A plus B plus I sine A plus B. Wow, this just makes life so much easier. However, look at these two things here. Because this is one line, everything is equal. So if we expand this, we will get cos A plus I sine A, that multiplied by cos B plus I sine B equals to the two angles. So expand the entire thing, cos A multiplied by cos B plus I sine A cos B plus I sine B cos A. I squared is -1, so that becomes a negative sine A sine B. Group all the real parts and group all the imaginary parts together. We get cos A cos B minus sine A sine B, and plus all the imaginaries, sine A cos B plus sine B cos A. And here we go. Let's group all the imaginaries and complex again. So this is all the real ones. That's the real one. And here's the imaginary one. That's the imaginary one. So now we can write this as cos A plus B is equals to cos A cos B minus sine A sine B. However, now we have sine of A plus B is equals to, because we only care about the magnitude of the imaginary part, imaginary components. Sine A cos B of sine B cos A. Let me have a look at my cheat sheet. Is it correct? Cos, sine, cos, sine, cos, cos, cosine, cos, cosine, sine. Yeah, that's correct. So since we have more time, why don't we just do negatives? So we have sine e to the power of IA multiplied by e to the power of I negative B. Yes, I'm not going to write this in a fraction because, no, I don't want to divide a trigonometric identity by another. So let's just leave everything in a flat line. So A minus B, that's equals to cos A minus B plus I sine A minus B. Didn't sine anything, I mean I multiply by sine A minus B. So as usual, expand this two little thing. We got cos A plus I sine A, nothing too weird here, minus B. Well, if you put a negative angle in cos, that's equivalent of putting a positive angle in there. However, if you put a negative angle in sine, that's equivalent of really just flipping it to the negatives. So sine B. Shouldn't put the brackets there. Why did I bother put the brackets? Well, it's already in there. Okay, doesn't matter. All right, whatever. So this is equals to that. So let's expand the entire thing. We get cos A cos B plus I sine A cos B minus I sine B cos A. And then we've got a negative I multiplied by I. That's negative 1. That becomes a positive 1. So positive sine A sine B. Group all the real parts. I'm going to skip a few steps here. Real one, imaginary, imaginary. That's real, that's imaginary. Group all of them together. We get cos of A minus B is really equals to cos A cos B plus sine A sine B. And here we go. The last one is sine A minus B equals to sine A sine b. Did I say sine b? That should be, I think did I meant to, oh, sorry, that's, I copied the wrong one. Yeah, these two are the imaginary ones. So sine a cos b minus sine b cos a. So look at how easily this is done. No complex, no adding random unit circles, no triangles required. You don't have to think about all these vectors, triangles nonsense. Just some simple algebra. And just expand the brackets, and you have the double angle formula. And then if you want to do triple angle formula, just put another one in there, expand 3 brackets. So easily done.